Welcome to the 6th video on buffers in our series of presentations on Chapter 14.6 from our textbook. In this video, we'll work through one of the in-class problems to determine how much acid we'll have to add to decrease the pH of a buffer by a specific amount. So the question from our Chapter 14 packet is how many milliliters of 2 molar HCl would we need to add to decrease the pH of the buffer that we previously made by 0.1 pH units? Let's remind ourselves of that previous buffer. Our buffer was made of formic acid, which has a pKa of 3.74, and formate. The total volume of the buffer was 1 liter, and the pH of the buffer was 4.00. We determined in the previous questions that the concentration of formic acid to give a buffer of pH 4 was 0.355 molar, and the concentration of the formate ion needed to be 0.645 molar. So this is the buffer that we're starting with. So what happens when we add HCl to our buffer? HCl is a strong acid that produces the hydronium ion. The hydronium ion will react with the base component of the buffer, in this case the formate ion, to produce formic acid. So the neutralization reaction is shown. Notice that we've used a single arrow to show this reaction. Because hydronium ion or HCl is a strong acid, this reaction goes to completion. Because the reaction will go to completion, we're going to use a stoichiometry table rather than an ICE table, and we'll do all of our calculations in terms of moles. Also notice that we are going to be having a volume change in this problem, so we'll have to do everything in terms of moles and then calculate concentrations at the very end if needed. So let's go ahead and show our stoichiometry table. I have put in the reaction, the neutralization reaction, and rows for initial, the stoichiometry change, and the final amount. So how are we going to fill in this table? Well, we're starting with a buffer with known concentrations of formic acid and formate. Recall that molarity is defined as moles over volume, so we can rearrange this equation to solve for moles. The moles of the component in a solution are going to be equal to the molarity times the volume. So we can use this equation to find the moles of formic acid and formate that are in our buffer initially. For the formic acid, we have 0.355 moles per liter. And we have 1 liter of that buffer solution, so that gives us 0.355 moles of formic acid. This is the amount we're starting with, so we're going to go ahead and put that in our initial row for formic acid. Similarly, we would calculate that we're starting with 0.645 moles of the formate ion. We don't know how much of the acid we want to add, that's the question, so I'm going to give that a variable and I'm just going to call it y. For the stoichiometry row, remember this is the row that we typically put our plus and minus x's. The reaction will go in the forward direction, so we'll have minus x for each of the reactants, and we'll have a plus x for the product. So in the final table, I'm just going to do an expression first. We have the initial with the change is y minus x. For the formate, we'll have 0.645 minus x. And for the formic acid, we'll have 0.355 plus x. One thing that we already know is that we want the acid to be the limiting reactant. So we want y minus x to end up being equal to 0. So that means y is going to be actually equal to x. So right now we really only have one variable in terms of these concentrations. Okay, so what else do we know? Let me go ahead and add a slide here. We know that we want to use the Henderson-Hasselbalch equation to solve for our concentrations. So Henderson-Hasselbalch says that the pH is going to be equal to the pKa plus the log of the ratio of the A minus concentration to the HA concentration. The pKa of the formic acid was 3.74, so we can put that in. And our original pH of our buffer was 4, but now we're trying to decrease it by 0.1 units. So we're going to end up with 3.90 as the pH of our buffer. What are we going to put in for the concentrations of the A minus and HA? Remember, the A minus would be the formate part of the buffer. And the expression that we had for the formate was 0.645 moles minus X. That's the moles, so we're going to have to divide by the total volume of the solution. We don't really know what the total volume of the solution is going to be because we don't know how much of the acid solution we're actually adding. So I'm just going to use VT as to represent total volume. It's going to be the 1 liter plus some amount of the acid that we're adding. What we're going to see is it's going to drop out anyway, so don't have to worry about it. So in terms of the HA concentration, we had 0.355 moles of the formic acid to start with. That's going to be increased by the addition of the acid. So we had our plus X from the previous slide. And again, to do this as a concentration, we need to divide the moles by the total volume. Okay, so now we have, well, we almost have one equation with one unknown. We need to do one more little thing. Notice that in this ratio, right, both terms are divided by VT, so we can cancel that part of the term. So rearranging, I bring the 3.74 over to this side, and I'm also going to go ahead and take the inverse log, so I'll sort of combine a couple steps here. So we have 10 to the 3.9 minus 3.74 will be equal to 0.645 minus x over 0.355 plus x. This term has a value of 1.445. I'm going to multiply across so I can combine my terms. Combine the x terms. And I can solve for x. Looking back at the previous slide, what does x actually mean? X is equal to the moles of acid that we want to add. The question asks for what volume of HCl solution would we add, so we need to finish this off by taking those moles of acid There's 1 mole of acid per mole of HCl. And the solution of HCl that we were adding was 2 molar. So there are 2 moles, 2 moles of HCl per every liter of HCl solution. And I'll go ahead and convert to milliliters. To find out that we're going to need to add 27 milliliters of the 2 molar acid solution in order to decrease the pH of our solution by 0.1 units. Notice that we had a buffer with a relatively large buffer capacity and that it takes 27 milliliters of a 2 molar acid to decrease the pH by just 0.1 units. Well, you made it. 6 videos on buffers. Congratulations. Hopefully after watching these videos, you're ready to complete the assigned problems in the group packet and to do the calculations needed for the buffers lab experiment.